Hi everyone and welcome to this tutorial. So as promised here we're going to do a small wiring to make our LED blinks. But first of all I want to come back to the last video. As I told you, it is important to insert a resistor to not fire your LED. Where when enough changes, we just add a resistor between the 5 volt of the Arduino and the anode of our LED, which correspond to the long leg of the LED. Okay, now let's move to blink our LED. Make sure to unplug your Arduino board from your computer, and then I invite you to change the pin of the Arduino. We're gonna place the pin number 5. We're gonna to place the 5 volt of our Arduino to digital pin number 13. Okay, it could be any digital pin like pin number 12, pin number 10, A, 7, 6, 4, to any other digital pin. But for this tutorial, we chose pin number 13. In other words, we connect the long leg of the LED, the positive leg called the anode, to the other end of the resistor. Connect the short leg of the LED, the negative leg called the cathode, to the GND. Don't forget the resistor. The resistor is essential for safe operation as it limits the current flowing through the LED, preventing damage to both the LED and the Arduino's output pin. After you build the circuit, plug your Arduino board into your computer, open your Arduino software. We're gonna we we're not going to make the code from scratch, but go to menu, get to your menu, file, examples, basics, blink. Right, a new window opens. Well, you have a bunch of command lines here. Let's delete those lines because we don't really need them. Okay, we delete this. Okay, we don't need those lines. Okay, okay, right. Oh, tap tap. Okay, we will do it quickly. Okay. Uh, we delete this and also this. But those who have enough time can read them, those lines that we have deleted. Okay. The first one, void setup, contains instruction that run only when the board starts up. The second one, void loop, contains instruction that run continuously in a loop while the Arduino is powered on. This is very useful for repeating tasks like blinking and LED at regular intervals. Okay, we do our program now. Let's modify the code right now. In the function void setup, we modify the LED built-in by red LED, red, uh, red LED, as our LED is red. Please, we have to declare this before and the number of the pin used here in is pin 13, and this is integer. So int, that means it is integer. Const, the number 13 is a constant. Red LED, okay, to 13, right? Okay, copy this and pass it to the loop, to the function loop, and also here, right? Very right. Okay. The number in the delay function is the time you take to light up and off your LED. Imagine that you're playing with your switch at home or you are doing a DIY repair with it. After repairing, you decide to switch on and then wait 1 minute to switch off. The light in your home will turn on and off if everything works well. This is the same thing. In the main loop, you turn the LED on with a line with this line. This supply 5 volt to the LED anode that creates a voltage difference across the pins of the LED and lights it up. Then you turn it off with a line, with this line that takes the red LED pin back to 0 volts and turns the LED off. Okay, in between the on and the off, you want enough time for a person to see the changes. So the delay command tells the board to do nothing. Okay, the delay command tells the board to do nothing for 1000 milliseconds or 1 second. When you use the delay command, nothing else happens for that amount of time. Okay, fantastic. Uh, we can verify what we did here. We verify the code. If everything is okay, perfect. Okay, the answer here is that there is any errors. That is fantastic. Okay, we can now upload the code to the Arduino board. Oh, sorry. Make sure that we have chose the right port here. Verify the type of Arduino that you have selected in your menu board, please. Okay, board Arduino. Make sure that it is Arduino UNO, and then we can upload the code in our Arduino. Thank you. The LED blinks correctly every 1000 milliseconds, so we can see it works very well. This first program is not very complicated to implement. We also protected everything thanks to a resistor which is much better. I advise you to do it if you don't want issues and to damage your Arduino or even burn your LED. Okay, so to sum up, this example shows the simplest things you can do with an Arduino to see physical output. It blinks the on-board LED. This example uses the built-in LED that most Arduino boards have. This LED is connected to a digital pin and its number may vary from board type to board type. To make your life easier, we have a constant that is specified in every board descriptor file. This constant is red LED. Okay, this constant is red LED and allows you to control the built-in LED easily. Okay, so blinking an LED is an introductory Arduino project in which we control an LED using Arduino. LED blinking refers to the process of continuously turning on an LED and off in a repetitive pattern. It is a simple and common demonstration in electronics and microcontroller-based projects. The setup and loop are two fundamental Arduino functions for controlling the behavior of your board. The Arduino framework automatically calls these functions which form the foundation of any Arduino program. Uh, the setup function is only called once when the Arduino board goes up or is reset. Its goal is to set pins modes, initialize variables, and execute any other necessary setup tasks before the main loop begins. This function can be used to configure that settings that should only be changed once over the board's life. The loop function is the art of the loop function is the loop function is the art of an Arduino program. After the setup function is executed, the loop function starts running repeatedly until the Arduino is powered off or reset. It contains the main code that performs the desired tasks, controls the board, and user input. Whatever is included in the loop function will be executed in a continuous loop, allowing the Arduino to perform its intended functions continuously. In the circuit diagram, okay, in the circuit diagram, we use one ohm resistor in series with the LED. This resistor is also called a current limiting resistor. The anode of the LED, the longer pin, is connected to one end of the resistor. and the cathode, the shorter pin, is connected to the ground. The other end of the resistor is connected to the Arduino pin. A step-by-step explanation is that first, the LED has two legs, the longer of which is the anode, the positive one, and the shorter of which is the cathode, the negative. We insert at one end of the resistor into the same row as the breadboard as the LED anode. The resistor's other end should be connected to the Arduino's digital output pin. We connect a jumper wire from the row as the LED's cathode to any Arduino board GND pin. This connects the circuit to ground of the Arduino. Uh, after After that, the circuit is completed. When you upload a simple Arduino program that controls the LED, the microcontroller on the Arduino board executes the program and the LED will blink according to the code you wrote. The LED blinking project is an important and straightforward method that can be utilized for a wide range of applications in microcontroller-based projects like security system, warning signals, in testing and debugging, also in status indication. Okay. To conclude, sorry, the Arduino LED blinking project provides a hands-on introduction to microcontrollers, hardware interfaces, and programming ideas. It serves as a foundation for more sophisticated projects and allows you to experiment with numerous Arduino features and capabilities. Whether you're new to electronics or an expert maker, this project will help you develop crucial skills and knowledge for future Arduino-based projects. So, this tutorial comes to an end. As you can see, it is not very complicated. Arduino should be tackled step by step in any case. I hope, I hope you enjoyed this tutorial, and if you did, please leave a little thumbs up. Subscribe to the channel if you haven't already, and I will see you soon for another tutorial. Bye bye.